This chapter deals with time value of money computations, and for us, we are going to be using our financial calculator, and we're going to be using what they call the TVM keys, which is the time value of money keys. So they're kind of right in the middle. And I have separate videos that actually put the calculator up on the desktop of my computer so you can see the keys up close and you can see how it's computed. So if you're struggling at all with using the financial calculator, go to those videos on actually how to key punch those in. Okay, so we're going to get into, there's a variety of different computations that we have in here. So we have, the first one actually isn't time value of money, but it's included in this chapter, and it's the present value of a perpetuity. So a perpetuity is something that you would expect to receive every year. So the example I use is, if the college is going to give a scholarship in somebody's name, and they say, okay, I want to give this $500 scholarship, in my father's name into perpetuity, which means forever and ever. So the key to that is that you never touch the principal. If you can continue to give something forever and ever, it means that principal remains intact, and all you're giving is the interest. So in this example, it says if you have the $100 perpetuity that you'd like to give, and the interest rate is 7%, what would be the present value? So what you do is you take the annual amount, which in this case is the $100, and then you divide it by your interest rate. So my interest rate, $100 was the amount of my perpetuity, and my interest rate was 7%. So that means I'd have to have $1,428.57 in an account that's earning 7% in order for me to do that. So that's the only one in this particular chapter that we really aren't going to use the time value money keys, but you still want to understand how to compute that value of the perpetuity. Okay, then the next one deals with uneven cash flows. And then that one isn't the time value of money keys, it's the row of keys right above it. It's our cash flow keys. So those are a little bit different, but still using the financial calculator. So if we have an investment that we get a different amount of money coming in, so we get $100 in year 1, we get $400 in year 2, year 3, and year 4, and then we get $300 in year 5. What's our present value of that? So again, instead of having to do 5 different net present values, using those time value money keys, we can just use our cash flow function. So our cash flow function is again the set of keys above it, and when you go into that, the first thing you're going to see is a cash flow for year 0. And in this particular problem, there's nothing. So our cash flow for year 0 is 0. Then if you arrow down, the next cash flow that you see, or the next field that you see is a CO1. And that represents, well, what's your first cash flow? For in this example, it was $100. But remember, you have to push the enter button to get these ones to recognize. And then when you arrow down, the next field you're going to come to is this FO1. And the FO1 stands for your frequency. So you only get that once. If this is the first time you're entering it, it'll just default to 1. If it has a value in there, you'll want to change it and then push enter to make it 1. Then my second cash flow in this example is $400. So I would type in 400 and then push enter. And then arrow down. And then in this example, the frequency is 3. We get it years 2, year 3, and year 4. So we'll put in a 3 and push enter. And then we arrow down. And then our last and final cash flow is 300. And then that is also a frequency of 1. If you can see that. Let me see if I can give it a little space there. Hold on. Okay, so that is your frequency of 1. Okay, then once you have all those into your calculator, and let me just double check, I was putting them in as we were talking, okay. So then the key to those though is always hitting that enter. Okay, then once you have all those in, then you come over to your net present value button, which is right beside it, and you push that, and then you say, okay, my I is equal to my required rate of return, and in this case it says the required rate of return is 8%. So we're going to put in an 8 and push enter, and then we arrow down, and that next field we come to is the net present value, and we push compute. And that gives me $1,251.25 if I round it. So that would be my net present value of this uneven cash flow stream. So anytime you have cash flows like that that are not the exact same amount every year, that's kind of what you're going to want to do, is put it into that type of a computation. Okay, then we have a loan amortization schedule. And then those will go back to those time value money keys. So those are our time value money keys. And we have a loan, it's a $10,000 additional mortgage. And that this additional mortgage is at a 10% interest rate, and it calls for semi-annual payments. So it's kind of like a supplement to a mortgage. So again, we've got 10 years as our N, semi-annual payments, so we'll multiply that by 2. So that's 20 semi-annual payments. The IY is going to be, the rate is, and it's 10% a year. So we need to divide that by 2. So that's going to be 5% each 6 months. The amount of the mortgage is our present value. It's what they've borrowed today. So that's $10,000. And with all loans, the future value is 0. So after you pay it for your 10 years, you're not going to owe anything. So we can zero that out. So 20 is the N, 5 is the IY, $10,000, make that negative by pushing the plus or minus button, is our PV, zero out the future value, and then compute that payment. So then the payment of this mortgage would be $802.43. So that's how much they'd have to make. If we wanted to amortize it, again, the calculator can do that. So we come over to our second menu, and then we push the PV button. And that takes us into our amortization function. You would again see it above the key. It would say AMORT, so that's cluing you in. That's the amortization. And then you really, depending on what the problem asks you, you can just do one payment at a time. So if you look, this is your first field. So P1 is equal to 1. And then P2, and if it's not, you can make it by putting in that and pushing enter. And then let's make P2 equal to 1. Then it amortizes the loan for us. It does all the work. So then all you have to do is arrow down. So then my balance is $9,697.57. If I arrow down again, the amount of principal that came out of that first payment is $302.42. And then if I arrow down a third time, my interest is $500. Then you can amortize any payment that way. So again, if you arrow down again, you start back up at the top. You could then make that a 2 and push enter, arrow down, make your P2 a 2 and enter. And then it says, okay, after your second payment, the balance goes down to $9,380.03. The principal is $317.55, and then the interest is $484.88. So, and then you could just keep going. So you could do the entire loan and amortize it that way. And again, you just want to be able to read it to know that, okay, this is saying after I make one payment, my balance of $10,000 drops to $9,697.57, which is a reduction of this principal amount, $302.42, and then the remainder of my payment goes to interest. And then it would trend on that way, where with each payment that you make, a little bit more goes to principal and a little bit less goes to interest. So then you want to be able to do that computation. And then our last one is a retirement computation. And I'm going to simplify this a little bit. It'll be comparable to one that's on your test. So if we have your father is 50 years old and he's going to retire when he's 60. And he thinks he'll live for 25 years after he retires. And he wants to be able to withdraw $40,000 today, or sorry, not today, $40,000 when he retires. Every year he wants to withdraw $40,000. He expects that he's going to earn 8% annually. So then the first, and then we're going to do it in 2 steps. So we're going to say, okay, first, how much does he need to have the day he retires? And then knowing that he has 10 more years to work, how much will he need to save to get there? So our first step is to calculate the present value of those future withdrawals. Because again, when you're in retirement, you're withdrawing. The whole point is that we are saving as we work so that when we get to retirement, we can pull the money out and live off of it. So then what we do is we focus on those payments in retirement. So again, going back to the problem, he estimates that he's going to live for 25 years after he retires. He estimates that his investment will earn 8% throughout that time. We're bringing this back to a present value, and he wants to withdraw $40,000 a year. And then this is the key, and this is what you have to remember. The future value is 0. When he dies, that retirement account can be 0 because he's dead. We're saving for retirement. Nowhere in the problem does it say he wants to leave a legacy to his children. He hopes to leave them $100,000. I mean, there's nothing in there. All it says is he wants to withdraw $40,000 a year. How much does he need to have the day he retires to be able to do that? So then just don't forget, 0 future value when we're focused on those retirement. So 25 is our N, 8 is the IY, $40,000 payment, zero out that future value, and compute the present value. So then that is $426,991. So we can leave the cents off. It's 5 cents, but we'll just stick to the whole dollar there. Then step 2. So then this is the first step. Okay, we have to calculate out the present value of the future withdrawals. Then step 2 says calculate the amount he needs to save annually to achieve this goal. And then if I go back to the problem, it does say, because obviously he's older, he has $100,000 saved right now. So then now we go back to our time value money keys. And then what we just computed here, because this is what he needs the day he retires, it becomes a future value. It becomes our goal. So our goal is for him to save or to have $426,991 the day he retires. He currently has $100,000 today. Make that negative though, or you're going to get the error on your calculator because he's starting with this. He wants to end up with that. He only has 10 years to save, and he's earning that 8%. So then we can compute the payment, which will be the annual amount that he needs to save. So coming back to the calculators, 10 is our N, 8 is the IY, $100,000, make that negative is our present value. $426,991 is our future value, and then compute the payment. So he would need to save $14,572.02 every year to achieve his goals. So that's a decent amount of money, but obviously, he's getting close to retirement. So the closer you get to retirement, and if you don't have a large nest egg, you're going to have to start saving. So then you want to be able to do those two steps, because those are both really necessary for calculating out retirement. And then that is really what I want you to know out of that chapter.